We are going to continue with section 2.1. Yesterday we talked about percentiles and z-scores, and today we are going to talk about transforming data. So what happens if we maybe convert data from inches to centimeters or Celsius to Fahrenheit. And then we're also going to talk about density curves, which is a way of taking our z-scores and having them give us a picture of what the population might look like. So as far as data transformations go, it can potentially impact our measures of center and spread. It does say shape here. We will see in a couple minutes that the shape pretty much remains unchanged for what we're going to be examining. There are two scenarios that we can run into. We can run into transforming data by adding or subtracting a constant. So this would be like if we had a curve and 5 points were added to everybody's test. Every individual test score goes up by 5. So when we do that, that's going to increase our measures of center or position, or center or location as it's worded here. So all of those values of the minimum, the quartiles, the mean, all of those are going to increase by 5. But your measures of variability are going to remain unchanged. So something like the range will remain the same because you added 5 to the bottom and you added 5 to the top. So the distance between them is still the same. Same thing with interquartile range. Q1 and Q3 both increased by 5. The distance between them is still the same. Standard deviation is a little more complicated, but if each observation increased by 5 and your mean increased by 5, then the distance between all of those observations and the mean is the same as it originally was. So standard deviation calculation is also going to remain unchanged. So here's an example where you can see two dot plots that are just the effect of adding or subtracting a constant. So this dot plot on the top, everything's just shifted to the right on the bottom. So as far as the number summaries, you can see a difference here between the mean, between the minimum, between the quartiles, the median, and so on. All of those differences here are 13, but your spread doesn't change. Standard deviation remains the same. IQR and range remain the same. They're just as variable as they were initially. You can also transform data by multiplication or division. So this would be like if we were going to transform from inches to centimeters, for example. And so here, when you multiply or divide, it's going to change your measures of center by that scale factor. Same thing with measures of position. So like your quartiles, your minimums, all those things are going to change by that scale factor. It also will impact your measures of spread. It does say here by the absolute value of B. The reason for that is because spread can't be negative. So for whatever reason that scale factor happened to be negative, you would multiply or divide by the absolute value of that scale factor. And then it's not going to change the shape of the distribution, which was the same that what we saw with addition or subtraction. The shape remained the same. The only thing to keep in mind here is that the variability is changing, so the change distribution will be more wide or more narrow, but if it started off skewed, it's going to stay skewed, or if it started off symmetric, it's going to stay symmetric. So here's our same example here. We're looking at a scale factor, and you can see that we just have this dot plot on the bottom is much wider than the one that's on the top. But other than that, everything is changing. The minimum changes, the maximum changes, the center changes. And you can see that in those number summaries here. It looks like it's a scale factor of slightly over 3 between the means, between the standard deviations, all the way through the whole chart. So the next thing that we're going to talk about is what's called a density curve. And actually, before we do that, I want to go back to the rules for transforming data. If you were looking at a transformation that included both multiplication and division and addition or subtraction, you would only apply what's applicable to the measure that you're trying to transform. So say it was some sort of linear transformation where we were going from x to y, and it was just y equals, we'll say 3x plus 4. If you're transforming the mean, we'll say the old mean was 2, mean is impacted by both multiplication and addition. So the new mean would be 3 times 2, which is 6, plus 4, which would be 10. But if you were looking at standard deviation, so the original or old standard deviation was 1. Standard deviation is not impacted by addition or subtraction, so we wouldn't add this 4 at all. We would just take the 3 times 1, that new standard deviation would be 3. So just kind of keep that in mind if you have linear transformations. The one that comes to mind is a Celsius and Fahrenheit conversion in your textbook. So when you see that, the mean's going to be impacted by both the plus or minus 32 and that 5/9 or 9/5, depending on which way you're going. The standard deviation is only going to be affected by the 5/9 or 9/5, not the plus or minus 32. Okay, so now on to density curves. So in chapter 1, we graphed distributions of quantitative variables. And now we're going to add to it what's called a density curve. So in chapter 1, we talked about these things. We said that we always plot our data. So we want to make a graph. So something like a dot plot, a stem plot, or maybe a histogram. You can make the box plots, especially if you're checking for outliers, but the box plots make it difficult to really pin down that shape. So one of these 3 up here is probably your best bet. So then you're going to describe shape, center, and spread. Again, you use mean and standard deviation if it's roughly symmetric. You use median and IQR if it's skewed or has outliers. Again, just identifying any outliers that you have. And then we can calculate those numerical summaries. So by using maybe a computer program or one variable stats on your calculator. But sometimes the overall pattern of our distribution, if the sample size is large, can be fairly regular. Maybe we don't have a whole lot of variability, and not variability in the sense of spread, but like the kind of up down of each of the individual bars. And you'll be able to describe it by a smooth curve. And that smooth curve is called a density curve. So as far as density curves go, they're always going to be located on or above the horizontal axis. And then this next one is really important. It has an area of 1 underneath the curve. And the reason that that's really important is because what we're going to do is we'll take a density curve and use the properties of that density curve to figure out what proportion of individuals, or here proportion of observations, fall within a given interval. So if we know what the density curve looks like for a height distribution, we can figure out what proportion of individuals fall within a certain range of heights based on the fact that we know the area under the curve. So here is an example where we have this histogram of students' vocab test scores, and then over top of it, this red line, that smooth curve, is our density curve. So we've been doing that when we were making dot plots and that sort of thing in chapter 1. We're now just going to call it a density curve and move forward with some of the properties of the curve. So here's a little comic for you. So the measures of center and spread that we learned in chapter 1, where we found like mean and standard deviation, that applied to data sets. It also is going to extend to density curves. And so the mean and median of a density curve are going to be dependent on the shape of that distribution. So the median is going to be located at the equal areas point, and then the mean is located at the balance point, because remember, the mean is non-resistant. Meaning that it gets pulled towards any outliers or skew. So if you have a symmetric density curve, both the mean and median are going to be in the center. If you have a skewed curve, that mean is going to get pulled towards the tail. So there are some example sketches down here for you. If you have something that's symmetric, like this one here, that mean and median are both right in the middle. It separates the area evenly on either side, and it also would be the balance point. Whereas here you have something that's skewed to the right, so your mean gets pulled towards that right skew, where your median isn't exactly at the peak, but it's at that equal areas point. So it's a little closer to the peak in this case. So in the case of a right skew, your mean will be greater than the median. So just an overview of section 2.1. We talked about percentile. Remember that definition differs slightly from what your textbook has. It is the percent of the distribution that's less than or equal to a certain value. And we learned about z-scores. Remember your z-score formula is the observation minus the mean over the standard deviation, or x bar minus mu over sigma. Again, remember parentheses around that numerator if you're going to type it all in your calculator in one shot. We also talked about ogives and how that can represent percentiles in the last section, and kind of think about what your quartiles and your median represent. So your quartiles, Q1 is really the same as the 25th percentile. The median is that middle value, so that's the same as the 50th percentile. Q3, the third quarter, is the same as the 75th percentile. And then we talked about transformations of data today. Again, just know the rules. So addition and subtraction is going to change measures of center and position, not measures of spread. Multiplication or division changes everything but shape. And then if we can describe a distribution by a density curve. We will learn more details about the density curves in section 2.2. But for now, really just knowing that the area under that curve is 1. And then when we look at the area between a certain range of values, that's giving us the proportion of a distribution that falls within that range. So you guys have a few homework problems for tonight, and then an optional Khan Academy on percentiles and z-scores.